the ability with maybe old kernels without the ability to use eBPF, maybe the kernel module is a solution for you. Falco can provide container context, of course. Events are already single-line JSONs, and Falco has many fields for filtering, about 150 for filtering for output, so we can add as much context as we need to our events. And Falco can be customized with plugins, but I need to say that in our own infrastructure, we don't use plugins, we use only vanilla Falco version. Let's look deeper. At the core of its logic, Falco uses the concept of a ring buffer to send events from kernel space to user space after the gathering. And it uses two main libraries, like library for system capture and library for system inspection. Yeah, first one is responsible for capturing all these events and tracking some system state, gathering the information. And the second one is responsible for enrichment, the data with this system state. So that's how Falco can provide some additional details, which is not available from the kernel perspective. And only after this, we will have rule engine work and some filtering based on rules. We have, yes, Falco works with the rules. These are several examples of possible detection use cases with the Falco. Why do we need Falco? What can we do with it? We can detect some malicious process activity. We can detect some attempts of creation reverse shells using duplication of main file descriptors like standard input or standard output to the network. We can track some network connections to suspicious addresses and so on, and many other interesting cases. Of course, it depends on the system call, it depends on the configuration, it depends, is it container or is it host, but there are different use cases useful for security. That's how Falco rule looks like. It has several important parts, but the most important thing is a condition. This is where we put our filtering logic, and if this rule triggers, we just get a message in the output in a human-readable format, along with a bunch of fields we decided to add. So we just need to add as much fields as we want and get this message to our monitoring solution. Yeah. Another cool concept in Falco rules is ability to use macros and lists. Macro is just a part of your condition. It's a reusable part, which makes your condition rules easier, shorter, and maybe easier to understand. You can see some examples here, like a spawned process is just a execv system call and the mentioning of exit from this system call. And lists are just lists. We can put some things here to reuse them again in our rules. These examples are from default package. I think they can be improved, and it's right. I will tell about it a bit later, but yeah, just several examples of macros and lists. And here you can see one Falco default rule for monitoring the creation of symlinks. And you can see here the usage of macro is a create symlink, and two lists, just maybe it's a good practice to monitor some actions in specific directories like process launch or symlink creation from, I don't know, TMP directory. It looks quite suspicious, and or something else. So we can put here any logic we want. Let me share with you some insights and internal details about Falco processing, Falco rules processing. We can put one rule file, we can put multiple files, so we can do here anything we want, but we need to understand and remember that rule loading matters. And inside the one rule file, we can also add different sections. And if we have similar parts in different rule files, I think we will have overriding, and we need to remember that only the last part will be final. So output fields amount doesn't impact on Falco performance. According to developers, maybe it can, but they told that it shouldn't create any visible additional load. First match wins. It's a default logic of Falco rule processing. So if we have different rules with the conditions, and if we have an event which matches the first rule, the processing will be stopped, and that's it. So we will have an output message from this rule. But this behavior can be overridden. It can be changed in the 0.36 version. So we can process we can process event from multiple rules, but we need to be careful with it because of opportunity to create additional load, additional resource consumption on our servers. And interesting part that Falco groups rules based on syscalls. So if you have an event, Falco will not send it through all your rules. It will send it only through group of rules with the same system call mentioned. So that's why it's quite important to mention syscall or syscall groups in your rules because of opportunity to change additional resource consumption. Yeah, and Falco, as I mentioned, adds some context through enrichment process. And it can add some details about container. It can add some details from, for example, Kubernetes metadata. And you can use this in your rules logic for your specific use cases. Let's talk about our experience and our challenges we had. I need to say that we started our work with the Falco maybe about 2 years ago. And the project now looks different. And also his and other tools in the market, like Falco, they also look different now, but I will just tell you about our experience from that time. When we started our project, there were two main candidates for this. It was Falco and it was Tetragon. You can see some differences here. The core feature of Tetragon that it has an ability to make prevention or to respond, but Falco is just an observability or security monitoring tool. It can just track, but not prevent. It can drop syscalls itself. So when we started this project, we tried to have a deep dive into these tools. And at that time, documentation of Tetragon and examples we had were quite poor. We tried to contact with the developers in the Slack. They recommended us to buy paid version. So it was quite difficult for us at that time. And rules syntax in Falco and in Tetragon is different. And with the small team, with the small amount of resources, we decided to start working with Falco, despite it process its rules and events in the user space. It was a concern, but we decided to start working with it, and we have nice results now. So one thing I want to mention about security tools in the servers, like Falco, like something else, you always need to put hardware limits for them, because they can suddenly start to consume more memory than you expected, or more CPUs, because Falco resource consumption directly depends on the load on the system. So if you have a really high loaded server, the Falco will need to process more system calls through it. And of course, at this moment, it will ask for more resources. And if you're familiar with Ansible, there is just an example of Jinja template syntax from Ansible. So for our general Linux servers, we decided to use C groups in the systemd units. And this dynamic logic to set limits for CPU and memory based on the resources available, but with a high limit. For Kubernetes, of course, we can use things like requests or limits to restrict Falco resource consumption in the daemon set. Another interesting part that with the Falco has different opportunities to send events to your monitoring systems. You can use HTTP, you can use gRPC, you can use different integrations, but with the big amount of events, sometimes it is useful just to use file system login and then pretty simple log shipping and sending this data with the batches to some system. But Falco cannot rotate logs itself, so you need to provide another small solution to solve with this issue. And in our case, it was just a log rotate with the custom configuration. You can see it here. The interesting point that we need to make like a post-rotate script and kill the Falco process during the rotation because it can stack on old file which was actually deleted. So it was an interesting feature or bug. Yeah. Another very important part of Falco is possibility of event drops. As I mentioned, Falco process events in the user space, so it needs to send unfiltered amount of system calls through ring buffer, and sometimes if you have a high load, these events can be dropped. And to be honest, it was almost the reason some time ago to remove Falco from our infrastructure, but fortunately, in some period of time, developers added a feature to set configurable ring buffer. So now we can use it with the different sizes. We can test it, and of course, Falco provides some metrics about drops. So we have several dashboards in our company for security. We monitor drops, we react on them, and we try to tune these parameters, these options, to make Falco work as stable as possible. I need to say that Falco does not provide kernel-level filtering opportunities right now, but this feature is being discussed. I hope maybe we will see it later, but let's see. Yeah, and here you can see just another example of Ansible code with setting different buffer size just based on the tag. So we can provide a special tag like Falco bigger buffer, and at that moment Falco will override the standard buffer size and put it into the variable of configuration file with a bigger value. What's wrong? What's wrong with Falco and similar tools in the market? Falco also provides great examples of rules as a starting point. Now they divide it into 4 categories. Only one of them is a production ready, other for testing, like sandboxing, like incubating, and so on. But we shouldn't trust these rules as is by default. We need to test it. We need to test them. We need to validate them. Because it's not a secret that Falco has several, there were several interesting researches about possible Falco bypasses. You can check this repository from BlackBerry to read more about these cases. So Falco is being actively developed. Some of these bypass methods are already mitigated, some of them not. But yeah, it's a general problem for rule or signature-based solutions. And Falco also has its own limitations and weaknesses. So sometimes we need to focus on different additional security measures to mitigate these problems with the Falco or other tool. It's not a secret. Very interesting part for us. Let's imagine you have a big hybrid infrastructure with many servers, and as a security team, you don't have an access to production environment, you don't have root permissions in your servers. Let's, for example, you have them in a testing part, but in production part, you don't have them. And in this case, if you want to manage rules with the tools like Ansible, I think you need to put some task on your SRE or DevOps team, send them this configuration, ask them to deploy it, and it's a really annoying topic. And these tasks could be done in days or even weeks, because guys from other teams have their own responsibilities, tasks from business and so on. So it was not suitable with such tool as Falco with its rich opportunities for rules development. So it was not good for us, and there is a solution. Falco uses really interesting concept for GitOps for rules. There is a small supplementary tool called Falco CTL. It installs with the main Falco binary during the initial installation, but this tool provides us the ability to put our rules as just as a YAML file to the OCI image. It's Open Container Initiative, like a container image. We can just put our YAML to this image and send it to the container registry. It is not an actual container image, but it's like a method to archive our rules and distribute them to different servers using registry we have in our company. And Falco CTL is also responsible then for capturing these rules on endpoint servers and updating them and tracking that we have the last possible rules in our server. Let me show you some details. Here you can see a couple of screenshots from GitHub Action example. So you can see the command on the second picture, like Falco CTL registry push, and this is exactly what we can do. So we store our Falco rules in a GitHub, for example, or GitLab or something else, somewhere else, and we can just put them to the registry, and after that to download them without, like in decentralized manner, and do not push them obligatory from one specific server. I need to go back a little back, and I just want to say that this step looks like a typical CD. It's like a continuous delivery part, but of course any pipeline should have a CI part, like integration, like testing, and we decided to add our own step to this just for rule validation. You can see this step here and the core logic at the lower part. So we just try to launch Falco with these rules and check, is it okay, or do we have any errors here? That's it. And this is the view from the container registry perspective. You can see that we have quite really lightweight images because they contain only several YAML files inside them, but we have a tag. The tag is from the branch of GitHub, or we can put it latest, we can do everything we want, but we can see that we have like an image with the latest rules we can download later. So this is from the server perspective. This is how Falco CTL configuration file looks like. You can see here that we just put a monitoring interval to every 30 minutes. We mentioned our rule files or rule images or artifacts in the reference section. So you can see it like Falco protect custom rules and Falco default rules with the tag mentioning. And that's it. And we provided here a couple of more sections like registry authentication data, authentication credentials. And we put here a very interesting part called index. Index is just another YAML file. It only contains some metadata about our artifacts, about rules, because artifacts can be not only rules, but also, for example, plugins. We can use the same ability to distribute our plugins, but here this story is about the rules. So it contains only some metadata like registry name, like some path, and so on. And here you can see just an example from guys from Falco. This is their image with the default rules from their repository, and yeah, that's how it looks like. So what do we have as a result? As a result, we have, in fact, a ready CI/CD pipeline with the Falco rules. We have our corporate container registry with the ready OCI images for Falco, really lightweight. So we shouldn't care about some drive consumption in the container registry. We have just an index file available from all our infrastructure without any credentials, just with metadata, just with links and places where we need to download our exact rules and artifacts. And we have this FalcoCTL supplementary service like systemd unit with the periodic check interval of new rules. The last part I would like to say is usage of Falco in Kubernetes. The most things I said before are applicable to Kubernetes environment, but I just want to make some additional mentions. Falco can be distributed in Kubernetes environment as a daemon set. It provides the ability to monitor every node, not only, for example, master nodes, but also nodes with the payload. Falco also provides many opportunities to detect malicious activity with the Kubernetes-specific attacks. It can also make some enrichment with the Kubernetes data. We can use now the same GitOps approach for rules management. Only thing we need to do is just provide proper FalcoCTL configuration file based using config map manifest. We can use these similar rules, so it makes some part reusable, but if we want, we can make additional rules, separate rules for Kubernetes. Yeah, but we need to think about logs capturing with the Kubernetes. For example, we can use tools like FluentBit as a sidecar container or as a separate deployment for logs gathering. And we still need to think about logs rotation, but it's pretty easy to solve this issue using like something like log rotate as another sidecar container. And I took this image from Falco website from one of their user success stories, and the scheme is pretty simple. So you can see here Falco, you can see FluentBit, and you can see that you can use this small agent not only for Falco logs capturing, but for example for capturing logs like Kubernetes own audit data. So that's it. Just one small holy war topic about using Falco or other runtime security tools based on signature detection method in the market. Typically, people are divided into two categories. Some of them think that signature-based method is good and it can solve all issues, but at the same time, there are people who don't believe it in this method, and they think that only profiling of your microservices can provide a real security. Maybe they're right, but I need to say that profiling microservices is also a very difficult and resource-intensive task. And if you have some actively developed microservices in your company, it may require a lot of efforts, a lot of costs to make this in an actual state. So, but at the same time, I need to say honestly that signature or rule-based tools have their weaknesses, they have their limitation, and we don't need to rely only on them in our work. So, just several conclusions. Falco is being actively developed. It is a powerful tool which can help you to significantly improve your monitoring capabilities in Linux, in Kubernetes. But at the same time, you must remember about its limitations and weaknesses, and you shouldn't rely only on Falco. And the most important conclusion here is defense and def is a key. So just make your security with several layers to mitigate the problems of each layer, and only in this manner of work you will be able to reduce your risks as much as possible. That's it. Thank you. If you have any questions.
Thank you very much. Thank you. Don't forget to rate the talk. We have a question already here to the left. 2 questions to the left. Oh, yeah.
I thank you for the presentation. I have one question. Do you apply your detection logic only in Falco rules, only on endpoints? Or do you have any SIEM solution for detection logic too, centralized?
Yes, I need to say that we, of course, we use CM as a place where we capture all these logs. We don't rely only on Falco logs. I need to say that we use Falco in 2 different ways. We have some really granular rules with specific conditions, but at the same time we do some things like all process launch capturing and do some filtering on the CM side too. So we are trying to combine these 2 approaches to have the best results.
Yeah, thanks.
Thank you. Here to the left, Artem, please.
Thank you very much. Maybe I missed the first part of your talk. So maybe you said about the performance of Falco. Do you measure the performance of Falco? As I understand, there could be 2 types of delays. The first one in the user space, performance Falco on user space, and the second one is the eBPF part, where Falco could make a delay of syscalls of another services.
Okay, I will try to answer as I understood the question. We had some benchmarking process about Falco. I can show this slide again here. Yeah. So first thing we decided to remove were the drops. So Falco provides some metrics for this. We also logged them and are logging them now. These metrics about some drops. We also look at some things like OM killer for memory, for something else, in Kubernetes and Linux service. So it was some small annoying work to tune Falco in different parts of the infrastructure. So we tried to make some stress tests. Falco has its own small testing solution for syscall generating and for the ability to see how it will proceed with them with the different sizes of these batches of syscalls. But I need to say that we didn't benchmark the eBPF part properly. I think it's quite difficult solution because I think you need a special software. Sometimes eBPF behaves not as you intended, eBPF sometimes can surprise you. So yeah, we have this task in our backlog. So we want to do it more proper than now, but we at least fixed the problem with the drops. We at least fixed the problem with the resource consumption, and now maybe we can start with the more granular tuning.
Thank you. We could discuss how to measure eBPF performance later, but we do the same for Tracy, and it give up about 100% of delay on syscalls. Is 2-time low performance we get, and this is a real problem that it could be used to bypass by adversary to bypass some runtime checks.
Yeah.
Thanks.
Yeah, I agree. Thank you.
Thank you. Okay, yeah, over here, gentlemen.
How do you review its output? So are messages routed to some Slack channel or in the alert management system like Obsidian or PagerDuty?
Yeah, I need to say that we send output messages from Falco to to file system logs in these servers, and we capture them using log shippers like FluentBit for Kubernetes, like other solutions for general Linux infrastructure. After that, we send them to CM, and in our CM we have different response channels, like we can send them to the Slack, we can send them to email, we can send them send some messages as webhooks to our internal automation systems. So mainly to messengers, but we also have some specific use cases with different channels.
Thank you. Any more hands, please? Oh, here. I remember you.
Thank you for your speech. We have some limitations with audit, with rate limiting. You should specify it because when you have a lot of syscalls, you will have delays in your kernel. I think the same will applicable to Falco with ring buffer. And for the servers, why do you consider user-level solution for monitoring applications, like injecting libraries into application? For example, as an example, libsnoopy for exec calls, and as a benefit of that, you have TTI as one of the parameters. And for Falco, could you have, in addition to syscall information, with TTI information to be able to differentiate user activity and service activity?
Okay, I will try to answer. Please correct me if I say something wrong. Falco has the ability to track some options, parameters like interactive process or like interactive process. So we can try to rely on some fields like shell existence or not. We can also rely on some things like a parent process and so on. But I need to say that Falco, because of its enrichment features in the user space, Falco